This video shows how to simulate the simple level control example with the Hybrid Equation Toolbox. First, open Simulink and select New Model. Then, go to the Hybrid Equation Toolbox and select Hybrid Equations Optimize. Here we have two blocks. The first represents a hybrid system without embedded input, and the second represents a hybrid system with embedded input, which is used to simulate interconnected hybrid system. In this example, we will use the hybrid system without embedded input. Take the block and drag it to the model. Now, in order to be able to extract the variables later, go to Simulink, Sinks, and select to Workspace. This block will save the system variables on MATLAB. You can take the block, copy, and paste it 3 times. Now connect the hybrid system output to each of the blocks. Name the variables. The first is going to be the state, and make sure you save it as an array. The second is going to be the continuous time, and the third is going to be the jumps. Now save your model. Now make double click inside the hybrid system block, and here we have the 4 elements of the hybrid system and 2 blocks that set the initial condition and simulation parameters and how the solution will be plotted. Now double click on flow map and a script will open to fill in the flow map of the system. In this case, we will use the code from the hybrid simulator block example to fill in the script. Go to the hybrid simulator block, select the flow map, copy, and paste it on the script. Now we have a flow map that contains the system constant, the state of the system, x1, which is the tank level, and x2, which is the pump state, the flow map, and the vector with the derivative of the states. Save, go back to the block, and double click on flow set. Go into the hybrid simulator block, select the flow set, copy, and paste into the script. The flow set describes how the system will flow. Here we have the constant of the system, the state, and the flow condition. Here the system will flow whenever the level is less or equal than the minimum and the pump is on, or when the level is larger or equal than the maximum and the pump is off. The system will also flow when the level is less than the maximum. In any other case, the system won't flow. We will save, go back to the block, and open the jump map. Here we will go to the simulator block, copy the jump map, and paste it on the script. Save. The jump map here will define how the system will jump. In this case, we have the same state, and the tank level will remain the same whenever a jump occurs, and the pump state will change to this opposite. Here we have the values for the states whenever a jump has occurred. Now we go back to the block, double click on jump set, go into the simulator block, copy the script for the jump set, and paste it on the script. Here, the jump set will define when the system will jump. In this case, we have the state and the jump conditions. The system will jump whenever the level is greater or equal than the maximum and the pump is on, or it will jump when the level is less or equal than the minimum and the pump is off. We will save and go back to the block. At this point, it's very important to check very carefully that all the possible values of the state variables are within the flow or the jump set, otherwise there may be errors in the simulation. And now we have defined the data for the hybrid system, let's specify the parameters and initial condition for simulation and how to plot the solutions. To do so, we will create a new script, go to the hybrid simulator block, into initialization script and copy the code and paste it on the new file. We will save it as tank ini. Here we have the initial conditions for the system. The initial level in the tank is going to be 1.8 and the state of the pump is going to be 1, which means it's on. The simulation horizon defines the length of the hybrid time. T indicates the maximum amount of continuous time and J indicates the maximum number of jumps. Here we have chosen the rule 1, which means priority for jumps, and the solver parameters tolerance and maximum step. We will save again, and now we will create a new file for the plots. We will go into the simulator block, copy plot solutions, paste it into the new script and save it as tank plot. This script will take the values for the solutions and present them graphically. Now we will go back to the block, double click in this block to link it with the file we already created, and select tank ini. Open, save, and now we can run our model. We make double click here to set the solutions to be plotted, and we got the plots for the results of our system. In this one we have the tank level as it evolves on continuous time, and in here we have the jumps that corresponds to each time that the value of the pump control was changed. With this, the example is ready.